Hi Science 10, this is our second video on 3.1 about chemical reactions and changes in energy during reactions. I just wanted to open with last day's solubility topic, and we were talking about how two substances, two ionic compounds that were clear like potassium iodide and lead 2 nitrate could react to make this very yellow looking precipitate in what was two clear solutions. And so using our solubility table, I hope that you gave that a try to check out whether it was the product potassium nitrate or lead 2 iodide that was the yellow precipitate. And checking on that solubility table, you would find out that this was the aqueous product and this was the guy that was the solid product. So then you would say that that yellow precipitate was in fact the lead 2 iodide. So moving on to today, we're going to finish up topic 3.1 in this video, and we're looking at the two possible energy changes when you react something and have a reaction happening and it turns cold versus having a reaction happen and it turns hot. If it turns cold, then that would be like a cold pack. That would be endothermic. And it would be one that energy was used up in order to start that reaction. So in this picture here, you can see the temperature going from 25 degrees to 24.8. That is significant enough to be an endothermic reaction. Opposite of that would be an exothermic reaction that releases heat, and anything that is burning, like burning a piece of wood, that would be exothermic, but so is cellular respiration. There is heat released, and that is what's creating cellular respiration is used to create our body heat, keeping us at 37 degrees Celsius. But things like glow sticks, also light is a release of energy as well. And there are, many reactions where you see steam coming off because of heat. Those are exothermic. So thinking about photosynthesis, when sunlight is used for the reaction, that would be endothermic, and cellular respiration, when heat is produced, that is going to be the exothermic, solar energy being used, endothermic reaction. So you can put those examples down in your notes. Okay, law of conservation of energy says that, we've heard this many times in science, but it applies here as well in reactions, that energy cannot be created or destroyed, but it can be converted from one form into another form. So we can't make it from nothing, but it can be something like chemical energy that is converted into light or heat, for example. So energy is required to break our bonds in a molecule, and when the bond is formed, then energy can be released. So it says here, if more energy is required to break it than is released, then that would be endothermic, and it would be feeling really cold. Whereas when less energy is required than released, then it would feel warm, and that would be the exothermic reaction. So now we might want to think about how cold packs work here, and it's a good idea to take a look at this, especially the cold packs video. It's very interesting. For the endothermic reaction, though, what we can write down is, for example, here, ammonium nitrate. When you add water to it and give it some energy, it breaks up into ammonia and nitrate separately, and it actually is going to feel cold. An example of an exothermic would be something like taking methanol and exposing it to enough oxygen so that would burn and make CO2 and H2O, which is basically burning any fuel. It would, including wood, would kind of do the same combustion reaction. If you add oxygen to a fuel and ignite it, you're going to get carbon dioxide and water plus energy. So you're going to feel the heat of that burning ethanol. So there's an example for you to put in your notes. All right. To wrap up this topic, we were going to take a look at the carbon tower. And what I'd like you to do is check out the video, Carbon Tower from Table Sugar. And it's the one that is 4 minutes. That would be a good one to check out. If you'd like to write down what it's all about, what happens with the carbon tower, you guys can write this down on the bottom of page 8, where it has information about the carbon tower, and that gives you an idea what you're about to see on the video. And you can anticipate that when we return to school, you will have a chance to see the carbon tower video. Sorry, not carbon tower demo, for real. Okay, so what we're going to do with this is take sucrose, and you guys can write this down, and add to it some sulfuric acid, H2SO4, sulfuric acid. And what will happen is a bunch of carbon, basically it'll look like a burnt marshmallow, but much bigger, is going to be released, and we're going to have some sulfur dioxide gas released and some water vapor released, and that will give us a whole bunch of bubbling. And the bubbles are going to like puff up that carbon, and there will be some sulfur dioxide gas that we have to be careful with. And so that's why this typically is done in a fume hood, or it's done outside. And the cool things, and you guys can check these out at the video, but you will see things like color change, so evidence of a reaction. You will see that they might talk about the odor given off, but it is there is a definite odor. There is gas produced in the bubbles, and you'll see the steaminess of it. There'll be heat released as well. So lots of evidence of a chemical reaction in this demo. It's an awesome one, so check out that video. All right, this wraps up 3.1, and I shall see you soon for 3.2. Bye for now.